Hi, I'm Ed Sperling. I'm the Editor-in-Chief of System Level Design. I'm here with Martin Lund, who is the Senior Vice President of SoC Realization at Cadence. Martin, in case the world has been asleep, we've noticed that you've been doing a lot of IP acquisitions lately. What's behind that? What are you trying to get to?
Yes, correct. We have done a number of important and strategic acquisitions over the past couple of months. We've announced Tensilica, we've announced Cosmic, and latest Evatronics. What we're putting together is a portfolio of high quality IP, very differentiated solutions, as well as top-notch engineering talents.
Mike Muller over at ARM has said that the Legos are getting bigger. The idea is that things will move from blocks up to subsystems and then to platforms. Do you see that as one of the options of where you're going, or even one of the directions of where you're going?
I'm a big fan of Lego. It's actually been a hobby of mine since I was a little kid. Lego is from Denmark. I'm from Denmark. I claim a sort of ownership over the Lego analogy, even though Mike probably have something there. Lego building block approach is important when we think about IP. We're putting together, we're building the elements that allows others to put chips together. But you never find just one big hunking Lego block. It doesn't work that way. You have to put together the key elements that allow people to differentiate. But it is true that the individual building blocks, people want to have 10,000 pieces. It takes too long to put it together. You're staying in the Lego analogy, so you want to have some level of subsystems or components that are pre-assembled so you can get to market faster. We are very focused on putting the right building blocks together, and some of them will be discrete components, like the wheel in a Lego assembly line, and some will be more comprehensively put together. We think of a physical layer device together with a controller, together with the software as a stack or a subsystem, and you can put these additional pieces together, and let's say you have a PCI Express controller and PHY and software next to a USB controller, PHY and software, and that can be an I/O subsystem. And that is all about not presupposing how the SoC is built, but putting together the solutions that allow people to get to market faster.
So one of the strategies of IP has always been get to market faster. But there's another piece that goes into it too, which says in addition to just getting it to market faster, it's also simpler to verify things that are independently created. So instead of a general processor, for example, you have multiple processors throughout an SoC. Is that one of the trends that you're seeing, and it is also one of the things that you're trying to do internally?
The value proposition of third-party IP or IP subsystem is obviously a time-to-market value proposition. It's also about having an optimized solution for a given problem or given solution that you need to have. For example, the Tensilica audio subsystem is market-leading, and it really allows people to get to market not only faster with less resources, but also to differentiate through more advanced capabilities. And so that's one aspect of the IP subsystem value proposition. The other one can be as simple as putting together a solution like a DDR controller with the PHY pre-integrated. A lot of work goes into verifying the discrete components, whether that's verification or time enclosure challenges. So we're trying to solve some of these problems or where wasted effort you can think of, where people have to go through it, but it doesn't really add to their differentiation. So it depends on how you look at it. We can look at the more complete solutions like an audio subsystem or LTE baseband modem solution, or a complete solution for a MIPI core with a PHY attached to it.
One of the intriguing things that's a future direction that you've brought up in the past has been, with this acquisition, your goal is to not only provide sort of standard IP, but also customizable IP for the masses. That sort of makes it very hard to think about how am I going to verify all these pieces, particularly when I don't know exactly what I'm getting, and IP has always been based upon really rigid characterization. How do you do that? What changes, and when do we actually expect to see this rolling out?
Ed, you're correct. The customizable aspect to our IP is very, very important. And it's important because the SoCs that are being built today and in the future will be different. They're not one size fit all. It doesn't work. You need to have small SoCs and medium-sized SoCs and large SoCs, and they all are solving different problems out there, whether they're running in an energy harvesting mode or running on a battery that's going to last for 10 years, or whether they run in a data center in the cloud. At different performance and power point, you need a different optimized solution. What we are taking is a different approach to the problem than trying to build a standard IP core that we then are reusing or modifying a little bit. We're really solving it from the bottoms up, and it's not just a vision. We have it today with the Denali memory controllers. We've delivered more than 3,000 uniquely different instantiations of that memory controller that meets very different performance and power and area requirements. The Tensilica architecture and base value proposition is completely aligned with that. You can modify the processing functionality and the cores for the specific needs. And so this is not just a vision, we're delivering it today. The verification challenge obviously is there, which is why when you have a unique configuration, how do you verify it? Well, at the heart of it, we're building the superset, and then we use the most advanced verification methodologies, including formal verification from our great EDA tools to very sophisticated methodologies for DV to get very, very high confidence that what we deliver is going to not only meet the need from the SoC perspective, but also be flawless.
One of the things one of the advantages that Cadence has, Synopsys as well, is that you're both developers of tools as well as the IP. Do you see that eventually going out, so when you buy an IP block in the future, you buy the tools with that? Is that an opportunity and also a competitive edge for the people that are working with that?
Well, at the end of the day, it depends whether our customer wants it. We prefer to partner with our customers and serve their needs and not try to force them into a business model they may not appreciate.
One thing you are doing with this entire strategy, though, is you're bounding the problem in a different way than it's been bounded in the past. In the past, you had to develop all the pieces and then you had to verify them. Now what you've said is, okay, here's the parameters you're going to work around. So it's almost the design industry's version of restrictive design rules, but with much more flexibility because you have the ability to trade pieces in and out. Is that what's happening from your standpoint, and where does this go in the future?
Yeah, it's a very interesting path. By us putting the pieces together, we can truly optimize the IP solutions that we deliver to our customers without having to worry about any methodology approaches or any other things. We can be the most aggressive in getting the right solution, whether that's adopting the latest and greatest tools from Cadence in verification or in layout or in simulation, and we can harvest those benefits without having to be held back by more of the white box model.
So putting this all in perspective, when you look at the semiconductor industry and the IP piece of that, how's all that going to go together? What do you see as the future?
Ed, this is exciting times. The industry is going through a transformation. IP is becoming much more important, and the individual building blocks that people are now being able to put together allow them to free up resources to go after differentiation, innovation. So we're enabling that trend to accelerate. And I believe that we're at a tipping point in the industry that we're not just going down, it's a mobile cell phone for everything. The application space is expanding dramatically from the power and fueled by the power of advanced semiconductor technology.
Martin Lund, thank you very much for your time.
My pleasure, Ed. Thank you.